So as we review and we think about graphs in Unit 2.4, in the previous slide, we looked at two graphs where both of them had positive slope. In slope-intercept form, they clearly had your slope in front of the x and then your y-intercept as your constant. But when we roll back to the first slide of our lesson, we realize that we had positive slope and negative slope, which we just addressed in the last video, but then we also had horizontal and vertical slope. And so what do those guys look like as equations? Let's take a look. So in this particular case right here, let's start with this guy first. So one way that we can look at this is, you notice if you think about slope-intercept form, it's y equals mx plus b. Well, in our case right here, we don't have an x. So that means that our slope would be equal to 0. So that'd be 0 times x plus 4, because whatever we plug in for x would turn into a 0 and thus disappear. So when we think about this and we start drawing a line or a graph of this guy, so to draw a quick little sketch, let's consider the concept using a table of values. So if I had a table of values and I chose some x values, like for example -2. So if I plugged in -2, that would give me 0 times -2 plus 4, which would just be equal to 4. So that would give me the ordered pair 0, positive 1, 2, 3, 4. So that first ordered pair would be right there, 0, 4. Let's consider another situation. Let's consider we plugged in, excuse me, my mistake. I was wrong there. Let me back up. It would be -2, my bad. I plugged in -2 for my x, so I'd be over here -2, and I'd be up 4, and that would put me right here at -2, 4. So if I plugged in 0, that would be 0 times 0 plus 4, which is equal to 4. So that would give me the ordered pair 0, 4. So I would go to the right 0, to the left 0, would just go up 4, and that would be 0, 4. Alright, last one, we'll try out +2. So 0 times 2 plus 4 is equal to 4. So that gives us the ordered pair 2, 4. So we go over, add some lines there, 1, 2. So we would go over 2, up 4, and that ordered pair would be 2, 4. We have enough points now to be able to create our line, or graph our line, excuse me. And we can see that in this particular case, that y equals a number would be a horizontal line, and our slope would be equal to 0. So we'll use this as the one that we can always remember. We'll use this as the one that we can plug into our graphing calculator and test, because we can actually plug in y equals 4 into our calculator and see what it looks like. And my calculator should be pulling up. I'm going to hit pause while it's working. So remember from our graphing calculator that we can hit the y equals key. We can clear off whatever's inside there. So in this particular case, we can hit y equals 4. We haven't used our calculator in a while, so we probably want to hit zoom and choose number 6. Zoom standard is 10 by 10. And so we can actually see the equation of the line. We can see that it's a horizontal line going across. We can actually go to the table, and we can see that no matter what x value we plug in, we get y value out. That y value is 4. So we're going to use this as the converse, or the opposite, in that if y equals 4 is a horizontal line, then x equals -2 would be a vertical line. And if you're a vertical line, then remember that your slope is undefined. So we draw our little xy axis, put some data values or some points on there. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we know that we have a vertical line that passes through -2. And so it's just that if you know this concept, then you can apply that concept. We know it's a vertical line if it's x equals. We know that the slope is undefined in this particular case. The other way that I remember this is that if I just took some random points like this point right here, that point right there is negative 2 comma 3. If I took this point right here, that point right there is negative 2 comma 0. If I took this point right here, that point right there is negative 2, negative 3. The point is that every ordered pair on that line, the x value is equal to 2. Just like on the y equals line, when it was y equals 4, if we look at every ordered pair on that line, the y value is equal to 4. So just kind of the opposite concept there. So vertical line, horizontal line. Let's slide forward. Let me hit pause and slide forward and make sure we got everything covered we need. So here's a couple examples to take a look at. What would be the equations? Well, clearly this is a vertical line. So by definition, our slope is undefined. This is a horizontal line. So our slope is equal to 0. This would be x equals 4. This would be y equals 5. Alright, last thing on this video, I just want to throw in like how we would graph inside of my math lab. So you can see we click on, even we've done graphing before, so you should have some of an idea, but you click on the tool to make it larger. We choose the kind of graph we have, so obviously this is linear. So we click on linear, and then we just plot 2 points. It doesn't matter which 2 points you use. I mean, you could, based upon what I told you, is that in this case here, my y-intercept is negative 3. So I would go down to negative 3, draw a dot. My slope is rise 1, run 4. See my slope right there? Rise 1, run 4. So at this point, I would rise 1, and I'd run 1, 2, 3, 4. And at that point, I'm ready to go. So I plotted my y-intercept, then I did my slope, rise over run. I save, and I check, and good job. So, and then the question asks, is it constant? Well, no, this is not a constant function, because a constant function would be one that is straight across, one that doesn't change. So this is not a constant function. And then we get into this topic of domain and range, which will be the next video.